Okay, welcome to this video. I'm doing this video to look at how to solve or how to determine limits that involve absolute values. So I've chosen some limits to go over here. I have 4 examples that I'd like to review. And the first thing that we need to do is remember the definition of the absolute value function. So here's how I'm going to write it. The absolute value function says if you want to know the absolute value of a number, it's either just the number itself, or it might be minus or negative 1 times the number. So the absolute value of a number is just the number if the number is bigger than or equal to 0, and it's multiplied by negative 1 if the number is less than or equal to 0. Okay, and so we're going to need this definition in order to compute these limits. So let's start with the first one here. For this problem number 1, we want to know the limit as x approaches 5. Okay, so I'm going to simplify what's written here in parentheses. So 10 plus the absolute value of x minus 5. I'm going to try to rewrite this in a way that is doesn't involve absolute values. So let's see here. So I'll have 10 plus the absolute value of x minus 5. Well, sometimes it's just 10 plus x minus 5. But then sometimes it's 10 minus x minus 5, right? And it depends on if x minus 5 is positive or negative. Right? So here I let smiley face be equal to x minus 5, right? So 10 plus the absolute value of x minus 5 will just be 10 plus x minus 5 if x minus 5 is bigger than or equal to 0. If x minus 5 is less than or equal to 0, then I need minus, right? So I can actually simplify this a bit because here x minus 5 is bigger than or equal to 0. That's the same thing as saying x is bigger than or equal to 5. So all I did was add 5 to both sides of the inequality. And now down here, x minus 5 is less than or equal to 0. Well, I can just rewrite that as x is less than or equal to 5, right? And now let's see this first formula here, 10 plus x minus 5. This part right here. I can simplify this to just 5 plus x, because the 10 and the minus 5, well, that's just going to be 5, and then I'll have plus x. So I'll have 5 plus x here, and then down here, 10 minus x, and then see how I have minus negative, so that'll turn into a plus, and I'll actually have 15 minus x, okay? So I can rewrite 10 plus the absolute value of x minus 5 equals 5 plus x if x is bigger than or equal to 5, and it equals 15 minus x if x is less than or equal to 5. So now, because I'm trying to take the limit as x approaches 5, and I have a formula that differs based on whether x is bigger than 5 or x is less than 5, this tells me that in order to compute this limit, I need to compute the limit as you approach from the left, and I need to compute the limit as you approach from the right, right? So I need to compute the left-hand limit and the right-hand limit. So there are 2 ways you can do this. One way is to sketch a graph of your function. So the function is a piecewise defined function. Sometimes it's 5 plus x, and sometimes it's 15 minus x. So let's do method 1, which is to create a sketch. Okay, so it looks like I'm concerned about what happens near 5. So I'm going to put a 5 right here, and then I'm just going to make some marks here. It's always good when you're sketching to add in a few values along your x-axis and a few values along your y-axis so that you have an appropriate scale. So now, from my formula, I'm supposed to use 5 plus x if x is bigger than or equal to 5. So if I draw 5 plus x for values where x is bigger than or equal to 5, I'm looking at a line with slope 1, right, and intercept at -5. So if I sketch that, now when x is equal to 5, this line is going to be at 10, right? So it's going to be a line through this point 10 with slope 1. So it's going to look like this. So it's here, if I go down here to 10, I'll be up to 15. Right, let me see if I can do a good line here. At 0, it should be at 5. Okay, that's not the best line. Let me try to see if I can do a better line here. Okay, maybe that's the best I can do. Remember, I'm removing this part back here because I'm only using the formula of 5 plus x when x is bigger than or equal to 5. Okay? So when x is bigger than or equal to 5, this is my line for my graph. And now what about when x is less than or equal to 5? If x is less than or equal to 5, then I'm looking at the line 15 minus x. So this is a line with the slope of -1, so it's going to be pointed towards the left, right, because the slope is -1. And let's see, if x is equal to 5, we'll be at 10. And if x is equal to 0, we'll be at 15. And if x is equal to -5, we'll be at 20. So this is going to be a line that looks like that. Okay, let me go ahead and draw that in. Okay, that was a horrible line. Let me try again. So it's something like that. Yeah? Okay, so I can draw the graph of my function. This is a piecewise defined function, and it kind of looks like an arrow. But now that I have this graph, I'm going to compute the limit. And again, because it's piecewise defined, and I'm trying to compute the limit as x approaches 5, I'm going to compute the limit as you approach 5 from the left. So the limit as x approaches 5 from the left, 10 plus absolute value of x minus 5, is going to be equal to, well, let's see here. As my x values get closer, what's happening to my y values? My y values are moving down, and it looks like the y values are approaching 10, right? So my values are getting closer and closer to 10. So my limit is 10, just by inspecting the graph. And on the other hand, the limit as x approaches 5 from the right will also be 10. So the values are also getting closer to 10. Okay, so I would say that since the limit from the left is equal to the limit from the right, the limit exists and is equal to 10. Okay, so that was method 1, is to use a sketch. And I'll show you another method. So here's method 2. Method 2 doesn't involve a sketch. All we need is this formula right here. We still need to look at left and right hand limits. So I can compute the limit as x approaches 5 from the left. Now, this is where I think, I don't have the picture to guide me, but I think if x is approaching 5 from the left, that means that all of the values of x are less than 5. So that means I need to use this formula, 15 minus x. So this will be the limit as x approaches 5 to the left of 15 minus x. And now, as x approaches 5, 15 minus x is going to approach 15 minus 5, right? And so I'll get 10. And then I can also say, okay, well, what about if we approach 5 from the right? Well, if we approach 5 from the right, then I need to use this formula, 5 plus x, because that's the formula for my function when x is bigger than or equal to 5. So I'll have the limit as x approaches 5 from the right of 5 plus x. And now, as x is going to 5, this is going to 5 plus 5, which will be 10. So again, I get that these are the same. So the limit exists and is equal to 10. So I'll just put that up here. Okay, all right. So let's do another one, and perhaps this time we'll do the second one, and I'll go a little faster, but hopefully the main idea is there. So I have 9 plus absolute value of 8 minus 2x. So the first thing I'm going to do is try to rewrite my function without the absolute values. And I'm going to say it's equal to 9 minus 8 minus 2x if 8 minus 2x is bigger than or equal to 0. And it'll be 9 minus negative 8 minus 2x if 8 minus 2x is less than or equal to 0. And so I'm going to now simplify this. Let me make this a little smaller. Okay. So 8x minus 2 is bigger than or equal to 0. That's the same as 8 is bigger than or equal to 2x. Divide both sides by 2, and I get x is less than or equal to 4. And then over here, I'm going to add 2x to both sides, so I have 8 less than or equal to 2x. And I'm going to divide both sides by 2, x bigger than or equal to 4. Okay. And now I can simplify 9 minus 8 minus 2x. So that's going to be 9 minus 8, which is 1, plus 2x, right? Because minus negative, it's going to give me a plus. And then down here, 9 minus, now notice I have a minus and I have a negative right here. Those cancel each other out, so I'll just have 9 plus 8 minus 2x. So that'll be 17 minus 2x. So when I go to rewrite this function, 9 minus 8 minus 2x is equal to 1 plus 2x if x is less than or equal to 4. And it's 17 minus 2x if x is bigger than or equal to 4. And so using my method, method number 2, I'm trying to compute the limit as x approaches 4, right? I have a break in my function at 4. So I have different formulas for my function based on whether x is less than 4 or greater than 4. So I need the limit as x approaches 4 from the left, and I need the limit as x approaches 4 from the right. Okay. So as x approaches from the left, that means that the x values are smaller than 4. So I should use 1 plus 2x. So I need to compute the limit of 1 plus 2x. And as x approaches 4, that's going to approach 8. And when I add 1, it's just going to approach 9. Okay, what about when x is approaching 4 from the right? Let's see here. So 8 minus 2x. That's going to be the limit. Now this time I'm going to use the formula of 17 minus 2x. So 17 minus 2x as x approaches 4 to the right. That's going to be 8 because as x approaches 4, 2x is going to approach 8. Oh, wait a minute. So 17 minus 8, that's 9. Okay. 9. Okay, great. So since these are the same, we say that this limit exists and is equal to 9. Okay. All right, now I think I already did this example, but maybe I didn't do this example in the lecture video, so I'll just go ahead and do it just to kind of save myself. Either I talked about it in the lecture video or I didn't, but we'll just do it just for good practice here. Okay, so we're working on this one, number 3. And again, the first step is to simplify my function, and I want to rewrite it without the absolute values. So on the one hand, I'm going to get t plus 1 over t plus 1. And that's if t plus 1 is bigger than or equal to 0. And then I'll have t plus 1 over minus t plus 1 if t plus 1 is less than or equal to 0. So now notice that I'm going to have a problem with my function if the denominator is equal to 0 because you can't divide by 0. So I'm going to go back here and actually remove the equality and make these strict inequalities. Okay. Now let's go in and try to simplify things. So now t plus 1 is bigger than 0. That's the same thing as saying t is bigger than negative 1. And t plus 1 is less than 0. Well, we can just write that. We can write t is less than negative 1. Okay, so already I'm looking down here. See how we're supposed to consider the behavior of our function at negative 1 or the behavior near negative 1? We're going to need to take our limits from the left and limits from the right because we're going to have different formulas based on if we're approaching from the left or from the right. Now, let's see how we can simplify this. Now, if I just have t plus 1 over t plus 1, that's just going to equal 1, right? And what about down here? If I have t plus 1 over minus quantity t plus 1, the t plus 1 here and the t plus 1 there are going to cancel out. So I'll just have 1 divided by negative 1. That's just going to be minus 1. So let me rewrite my function here. So t plus 1 over the absolute value of t plus 1 is either equal to 1 or negative 1. So it's 1 if t is bigger than negative 1, and it is negative 1 if t is less than negative 1. So if we were to sketch this, it'd be pretty straightforward to sketch. My point of interest is negative 1. And now I'm going to go and just write, if t is bigger than negative 1, my graph is 1. Okay, that should be straight. Let me try again. If t is less than negative 1, right, so if I'm looking at values where t is less than negative 1, then my function is always equal to negative 1. So I'm going to be down here. So my graph is down here. I'm going to put a hole here because we don't know what happens when t is equal to negative 1. This function is not defined when t is equal to negative 1 because you can't divide by 0. And I can't say 0 over 0 equals 1. I can't say that, right? You can't divide any number by 0, not even 0. So this is a graph, and I guess I'm using method 1. And I'm trying to see the limit as t approaches negative 1. The limit as I approach from the right is going to be 1. The limit as I approach from the left is going to be negative 1. So because the left-hand limit is not the same as the right-hand limit, this does not exist. Okay? Now let's do one more, this last one here, number 4. And it's another ratio. You know what to do by now. You can probably walk me straight through this. The first thing we'll do is simplify our function. We'll rewrite it without the absolute values. So this is going to either be 2w plus 10 over w plus 5, or it'll be minus 2w plus 10 over w plus 5, right? And that depends on if 2w plus 10 is bigger than or equal to 0, or if 2w plus 10 is less than or equal to 0. Now let's try to go back in and simplify some of this stuff. So 2w plus 10 is bigger than or equal to 0. That's the same as saying 2w is bigger than or equal to negative 10. And if I divide both sides by 2, w is bigger than or equal to negative 5. Now remember, if you are dividing by a negative number, you have to flip the inequality. But here we're dividing by a positive number, so we don't have to flip the inequality. Okay, down here, let's look at this inequality and see if we can rewrite it. It should be pretty similar, so it'll be 2w less than or equal to negative 10, and then divide by 2, so we'll have w less than or equal to negative 5. Okay, so negative 5 appears to be our little hot spot, and that matches with the fact that we're computing the limit as w approaches negative 5. Now, let's go back to our function. Can we simplify 2w plus 10 over w plus 5? Yes, yes, we can. The numerator is twice the denominator, right? So this is going to simplify to just 2. And what about here? Well, exactly the same thing applies. That's going to be equal to 2. So all of this is going to be equal to negative 2. Now, the only thing we need to do, just if we're going to be really picky and be very, very careful about what we write, I'm going to go back in and I'm going to remove the equality, because if w is equal to negative 5, then this isn't defined. That means we would be dividing by 0, right? Which is not good. We're not supposed to do that. It's not defined, right? So I'm going to remove that. And now this one is similar to that last one we did, where I can sketch. I'll do method 1. I can sketch because sometimes my graph is 2, and then other times my graph is negative 2. So the cutoff point is at negative 5. So here's negative 5. Okay, and now sometimes my function is 2. So it's 2 if w is bigger than negative 5. And it will be negative 2 if w is less than negative 5. Okay, all right. So I'm looking, this is my sketch of the graph. And as I approach negative 5 from the right, my values approach 2. As I approach negative 5 from the left, my values approach negative 2. So since the left-hand limit is not equal to the right-hand limit, you guessed it, this limit does not exist. All right, I hope this was helpful. As usual, please do not hesitate to let me know if you want me to do a few examples or make a specialty video. I am here to help you, and I love doing it. All right, let me know if you have any questions about anything in the video too.